we go. This is going on page 84 when we're done. Okay, still working with exponentials and logs. So this starts off by saying previously, which means we already did it, we looked at inverse functions, finding the inverse of all kinds of things, including exponentials and logs. In these forms here, we are now going to look at inverses with some more transformations in them. Our inverse steps don't change. You switch x and y, you find the inverse, you write it in the correct notation. Kind of same process every time, just looks a little bit different depending on what kind of equations you have, right? So we start with this one. We're going to find the inverse. So instead of f of x, we're going to write y, right? And then we start by switching x and y. So we'll get x equals 3 times 2 to the y plus 4 power minus 15. Right? So that's my inverse, but I have to solve for y so I can use the correct notation. So what's the first thing we're going to do? Add 15. Okay, so x plus 15 is equal to 3 times 2 to the y plus 4 power. Okay, yes, because at this point I have just one term on the right-hand side, but my exponential is not isolated yet because of this 3. So we're going to divide both sides by 3. X plus 15 over 3, got it, thank you, equals 2 to the y plus 4. Okay, one second. Thank you. What's your question, hon? You could do x over 3 plus 5, but it's probably better most of the time if you just leave it as 1. Because even though, yes, that would be 100% correct, if you didn't at some point divide 15 and 3 correctly, because have we ever messed up on something like that? Yes. It's just not necessary, so I wouldn't do it. Okay, but it's not wrong. Okay, that's a good question. All right, everybody okay at this point? I know. It actually would be helpful. Yeah, because second period just stares at me, so, you know. Yeah. All right, so this is, so now that it's isolated, I can rewrite it, right, in log form. So log base what? The base of log of x plus 15 over 3 equals y plus 4. And then I got one more thing to move. Log base 2 of x plus 15 over 3 minus 4 equals y. Then we want to put it in the correct notation. So f inverse of x is equal to log base 2 of x plus 15 over 3 minus 4. Exactly. We're just kind of putting it all together. Just every day we're stretching things out a little bit more. How did I know it was log base 2? Because when we rewrite an exponential, the base of the exponential becomes the base of the log. Okay? Anything else? You good? Okay. Now, look at example 2. We're doing the same thing, but instead of, not the same thing, obviously, but instead of taking an exponential and making it into a log, because we're doing the inverse, we have a log and we're going the other way. So I'm going to give you a minute to work on that one on your own. You can do this. Any questions at all? Okay, so one thing I want to point out that I pointed out on, I think, a previous lesson where we had some sort of rational expression in there is that we could have done all of this 100% correct, that been our answer, and if this was multiple choice, maybe that doesn't match an answer choice, but we're pretty sure we're right. One thing that can happen, and it depends on, it may not have happened to anybody on this question, but on some of the others, depending on which side of the equal sign you move things to or whatever, if you have a rational part in there, this could also be like another correct answer, or even on the answer key, like if it doesn't match exactly, maybe it's a different form. Instead of x minus 6 over negative 3, it could be 6 minus x over positive 3 plus 4. Basically, if you change every sign, the sign on each term in a rational, then it has the same value, okay? So I'm throwing that out there just in case you're like, I'm pretty sure I did it right, but like, and it kind of looks similar. I mean, those don't look super similar when you glance at them, but if I switch the sign on every single one of them, it totally works, okay? Yeah, if you think it through, it works, you know, it works. Only for the fraction part, and just on the fraction part of that, okay? And again, maybe it won't come up at all, or maybe it's just when you're checking your answers, but it is definitely a something that could happen. Mm-hmm. Oh, just this part in parentheses? Absolutely, 100%, totally fine. That works. Anything else? Those are good questions. Okay, let's look at example 3. So we have h of x is equal to this, k of x equals h inverse. For what values of x does k of x equal 1? All right, so in order for me to figure out when k of x equals 1, I have to figure out what k of x is. How am I going to find k of x? Find the inverse of h, right? Let's make that into y. We'll just do this together, so that gives me x equals 3 to the y plus 1 minus 2. All right, so then x plus 2 equals 3 to the y plus 1. Now what can I do here? Log. Good. So log base 3 of x plus 2 equals y plus 1. So log base 3 of x plus 2 minus 1 equals y. So then that means that k of x, which is equal to h inverse of x, is equal to log base 3 x plus 2 minus. Okay. Everybody with me so far? Okay. So now that I have what k of x is, I want to know when does it equal 1, so I need to set it equal to 1. So log base 3 of x plus 2 minus 1 equals 1. So I'm about to solve this log equation, right? Do I need to pay attention to the domain? If I solve a log? Yes. Okay. Now, the other two we just did, we weren't solving. We were just finding the inverse, so that was irrelevant. But when I solve this, if I'm going to get an x equals something, then I got to know if that falls in the domain, right? So I'm going to do this x plus 2. I know that has to be greater than 0. So x has to be greater than negative 2. All right. So now I can add 1 to both sides and get log base 3 of x plus 2 equals 2. Then I can rewrite that as 3 squared equals x plus 2. So 9 equals x plus 2. And x equals 7. So does that fall in my domain? Yes. So then I can say k of x equals 1 when x equals 7. Okay. What questions you got? We good? You getting better and better at manipulating these logs? The more we work on them? Good. Alrighty, flip it over. Let's talk about some inequalities. So once again, we have this previously, which means we've already done it. We solved inequalities of polynomials and rationals We found x coordinates that had zeros, holes, or vertical asymptotes. Then we used a sign chart. So we're doing back to sign charts because it's more inequalities. And so we can do this with exponentials and logarithms the same way, except actually it's much simpler when working with them, believe it or not. So let's see what's going on here. We've got f of x equals this log. What are all the values of x for which f of x is greater than 0? All right, so then I need to make this a little inequality here. Log of x squared minus 4x plus 7 minus the log of x plus 3 is greater than 0. All right, so inequalities and equations, we work with them in very much the same ways. The inequalities have some other properties we have to do, but if we're still kind of thinking about this like we would solve it basically like it's an equation, that means I have to pay attention to my domain. So we need to go over here, figure this out. Say, all right, well that means that x squared minus 4x plus 7 has to be greater than 0. Then what would I do to figure out my x's? Okay, so we're going to factor. If C is positive, that means this, excuse me, that means the signs are the same. So the signs have to be the same, and 4 is negative, so they both have to be negative. What are the only numbers that multiply to give me 7? 1 and 7. Are they going to subtract to give me negative 4? No. So then can we factor this? No, but that should be your first line of defense. Like that's the first thing you're going to try, and it doesn't work. Okay, we can't factor it. Doesn't mean we can't do anything, but we can't factor it. What is another way to solve a quadratic? Close. Quadratic, what do you mean by, well, that is a quadratic equation. Quadratic formula, okay? So if you know the words, which you should, sing along. You can sing. There you go, sing along. Look, it's dark, nobody can tell it's you. There we go. Sing it. I'm going to keep playing it till you sing. Okay, again. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2. All right, last time, loud and proud. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Good job. I'm putting this in the playlist. You might need to play it over and over again while you sleep so it seeps into your brain if you don't know it. Can I guarantee that you have to use the quadratic formula on the AP exam? No, but in the CED, does it say that you have to be good at solving quadratics, including factoring and quadratic formula? Yes, that is listed as a skill, so it very well could come up. All right? There's other things where I can say, yes, you're going to have questions that ask you this and that. This, maybe, maybe not, but you got to know how to do it just in case. So let's do this. So instead of x equals, it's going to be x is greater than, okay, so it's negative b, which is 4, plus or minus the square root of b squared, negative 4 squared, minus 4 times a, which is 1, and I'm running out of room, so I'm not going to write the 1, times c, which is 7, all over 2a, which is 2. Okay? Now, before we do anything else, okay, let's think smarter, work smarter, not harder, right? What's negative 4 squared? 16. And what's 4 times 7? 28. So 16 minus 28, which is going to give me what kind of number under the square root? Negative. I don't even care what the actual number is. I'm going to get a negative number under the square root. So am I going to get real values out of this? No. So then it's kind of irrelevant, right? By doing that, I know that I'm not going to get anything that works because since this opens up, basically my quadratic's doing that and it doesn't cross the x-axis. So it's always greater than 0. Does that make sense? So that is not going to work. So I don't need that. Now, that doesn't mean every time that the quadratic formula comes up that it's irrelevant, but that in this case it is. You with me? Like we had to try it, but then we're not getting anything that's going to help us. So then we do the other one. X plus 3 has to be greater than 0. No. Then x has to be greater than negative 3, and that is the domain. How else would you have figured it out?
No, I just mean because it says like plus 7, so it would be like y-axis.
That's not what that means. That only means that if it's in a certain form. Not always just plus 7. All right, so that is my domain. We good on that? Okay, so now I'm going to come back over here. We're going to treat this like we do, like kind of semi-pretend it's an equation, meaning we're going to use our log properties over here. I'm subtracting them, so that becomes 1 log with division. And that's greater than 0. Okay? So now I have my log isolated. I can rewrite this, all right? And I went back and forth on how I was going to show you how to do this next step because there's good and bad to both of them, but I kind of let second period vote, so they voted on this, and I kind of agree with them. So if this was an equal sign, we would do 10 to the 0 power equals this. You agree with that? So we're still going to do that, but because we want to do it in that order, because that's what we're used to doing, when we do that, this 10 to the 0 power, we have to flip this sign around. And it has nothing to do with the rule where you flip it because you're dividing or multiplying by a negative. It has to do with just the way the logs are set up. So I think it's probably best if you just go with because I said so at this point. You know what I mean? Like I'm not a big fan of saying that. Like I would rather explain to you kind of why, but I don't think you really want to know. I think you just go with it, okay? Yeah. It's just because I said so. Because if the log, yeah. Yeah, no, I just.
What are you saying?
What am I saying? I'm saying you make sure the log is on the left, you rewrite it like we have been, and just flip that sign. That's all I'm saying. Because I said so. We're not going to go into the why.
Oh, I didn't care.
You didn't care why, I know. Most people don't, but I think for some people it kind of helps you understand and stick with it, so we're going to go with because I said so. Now, 10 to the 0 power is what? 1. So we're just going to do it that way so we don't have to rewrite again. Okay? Plus, I'm also going to show you something else we could have done here, and I'll tell you why we didn't once we get there, but because you're going to say, well, that would have been easier. I know, but there's a reason I did it this way. So we're going to multiply both sides by the denominators, so I'm going to get x plus 3 is less than x squared minus 4x plus 7. I have a quadratic again, so I'm going to get all my stuff on one side. So 0 is less than x squared minus 5x plus 4. Okay? Then I'm going to factor. We'll try to factor. Let's see if this one factors. Can I factor this one? Yes. My numbers are -1 and -4. So x is equal to 1 and 4. Okay. Everybody with me so far? Like so right now I'm solving it just like I would if it was an equal sign. The only thing that happened was that I had to flip that around, right? But now that it's an equality, I need to do my number line. So on my number line goes my zeros, the 1 and the 4, but also my domain, because the reason I have this domain and I can't use all real numbers is because I have a vertical asymptote, right? And when we did these for rationals, we had to put our vertical asymptotes on there as well. So -3 goes right here. Because I'm not going from -infinity to 1 because I can't. I'm only going from -3 to 1. So anything that's on this side of it is completely irrelevant. I don't care about it because I can only start with -3. Okay, we're good on that? All right, so now I'm going to choose numbers. Between -3 and 1, I can choose 0. So that would give me negative and negative, which makes this positive. Between 1 and 4, I can choose 2. Which, when I put it in here, this is going to give me positive negative, right, which is negative. And then above 4, this is going to give me positive positive, which is positive. Okay. Then I have to decide what the heck I wanted. Now, I know that I have this right here, but remember, we just manipulated a whole bunch of stuff, so I really kind of want to look at this. I was trying to figure out when is this function greater than 0, which happens to be, my f of x as we work stuff around. When is that greater than 0? So I'm looking for the positives here. So then I can say f of x is greater than 0 on, because you do things on an interval, -3 to 1 and 4 to infinity. Everybody okay with that? Any questions? All right. So let's do another one. This time, instead of giving us one function, they've given us two. We have g of x, which is this, h of x, which is this, and we want to know what values of x for which g of x is greater than h of x. Okay? So let's set that up. G of x, which is the natural log of x squared plus x minus 5. I want that to be less than the natural log of x plus 4. Okay? So now that I've set that up, I want to check out my domain so I don't forget to do that. And I'm going to have x squared plus x minus 5 needs to be greater than 0. Is that one going to factor? What are the only two numbers that multiply to give me 5? Okay, 1 and 5. Are they going to add or subtract to give me 1? No, so it doesn't factor. So we're going to do quadratic formula. So x is greater than. So negative b, that's -1, plus or minus the square root of b squared, so 1 squared, minus 4 times 1 times -5, all over 2a, or 2. Now, under the square root this time, am I going to get a negative number? No, I'm not. This is going to give me x has to be greater than -1 plus or minus the square root of 21 over 2. Now let's think about the whole reason we're doing this. We have to figure out what our domain is going to be, right? And this gives me two answers, okay? And I know if I do -1 minus whatever, that's still going to be negative. -1 plus the square root of 21. Now, whatever the square root of 21 is it bigger than 1? Yes. So when I do -1 plus that over 2, I'm going to get a positive number, right? So of the two numbers that this produces, we know which one of those two wins out in being bigger. You with me on that? Like, I don't even care what the actual estimation is, but I know of those two that x would have to be greater than -1 plus the square root of 21 over 2. So we're using some logic and reasoning, not necessarily getting decimals, because you would not get a calculator on this part, because if you did, we'd solve it in a totally different manner. Okay? So we all good with that so far? Now we still have to take into account this other one. This x plus 4 has to be greater than 0, which means x has to be greater than -4. Well, of these two, which one wins? This one, right? Because we know it's positive. That may be all we know, but we know it's positive. So that's our domain. Okay? Everybody okay on that so far? We don't have to know any more right now because we had one positive and two negatives, so that has to be the one that wins. All right. Now we come back over here. And so I have a natural log on each side. They're both isolated. Do I have to do some fancy log stuff, or can I just drop the logs? I can drop the logs. So this is just going to give me x squared plus x minus 5 is less than x plus 4. And then we're going to pause right there for just a second. And we're going to go back up to this one. Here, when I had these two logs and I was subtracting, we did our log properties and went from there, and it was fine. But I could have taken this part and added it to the other side and kind of been in the same situation I was here. Does that make sense? And then I could have just dropped the logs. The reason I did not do that is because I can't guarantee that every time you have an inequality, you won't have some number or something over here. Okay? And then if you did have some number, then we would have to use our log properties. We would have had to do it this way. But in this case, if you don't want to have to do this and flip around and whatever, if you just have two logs and the only other number there is 0, then you could move it over and be in this situation here. Okay? But that's why I didn't do it, because I wanted you to know what to do if you needed to. Okay? We good on that? All right, so now that we're here, we can finish up this algebra here. I'm going to move everything to the left. So x squared, then the x is 0 out, then minus 9 is less than 0. Can I factor that? Yes. This is x plus 3, x minus 3, less than 0. So x is negative 3 and 3. So on my number line, oh, that's my question. Where did we go from inequality to equal sign? Right here? Because those are the x values that we get. This doesn't have to be, x doesn't have to be less than negative. That's what we're about to figure out. When you solve this, this is what you get. And if you have either one of those answers, then it's less than 0. Like those are, we're done with the inequality once we get here. Okay. So on here, I have my negative 3, and I have my 3, and then I also have to use my domain, okay? Now, one thing I know about my domain is that that crazy number over there is positive, right? So I know it's greater than negative 3. I got that down. But now I got to figure out if it's which side of 3 it goes on, because that's going to matter. The square root of 21 has to be between which two numbers? Which two whole numbers does it have to be between? 4 and 5. Because the square root of 21 is between the square root of 25 and the square root of 16, right? So that means this is 4, this is 5, this is somewhere between 4 and 5, okay? So somewhere between 4 and 5. If I add a negative 1, then I'm somewhere between 3 and 4, yes? So somewhere between 3 and 4, and I divide by 2, am I going to be greater than or less than 3? Less than 3. And that's all that matters. Like what the actual decimal is doesn't matter. But I know I'm somewhere in here. This isn't to scale anyway, so that's fine. I'm in here, negative 1 plus the square root of 21 over 2. See how just a little bit of number sense and being able to reason? Nobody's asking you to go over and estimate the decimal. It doesn't matter. But what does matter now is understanding that since all my x's have to be greater than that weird yucky number, that everything to the left of it is out of commission, right? Even though negative 3 was on there, I don't worry about it. I got to worry about in between these two and here and beyond. So since I don't really know what that estimate is, and I don't really care, it's not worth my time or brain cells, if I want to choose something between those two, I can choose 2.9 repeating, right? Just really, really close, just right on the other side of 3. If I put 2.9 repeating in here, is this going to be positive or negative? Positive. 2.9 repeating in here, what do I get? Negative. So this is positive times negative. This is negative overall. If I substitute in 4, I'm going to get positive, positive. This is positive. Okay? So now let's figure out what we were looking for. Yes, we were looking for this, but we manipulated a bunch of stuff. So really this was kind of where we ended, trying to figure out when is this less than 0. And it is less than 0 when it's negative, so that's this part right here. So I can say g of x is less than h of x on the interval from negative 1 plus the square root of 21 over 2 to 3. And that's my interval. I know. God forbid I make you think. So sorry. But you can think through this. But notice that you don't have to solve everything out 100%. Who cares if we don't know what the value is? You have enough reasoning skills to be able to figure out what the values are and how they go. Okay? What questions you got? Anything? All right. So let's look at this last one here. We've got k of x is equal to this function. What are all the values of x for which k of x is less than negative 31? So I don't have to find an inverse or anything. I just need to take k of x, 1 minus 4 times 2 to the x minus 3 power, and figure out when it's less than or equal to negative 31. So I'm going to give you a minute to work on that. Don't forget your inequality rules about having to flip the sign when you divide or multiply by a negative. Oh, yeah. I mean, we don't do inequalities a ton, but when we do, you got to remember the rules, right? Any questions at all? Alrighty.